welcome to this class. Today we are going to center our discussion on ideal gas equation. We are going to look at the simple method to prove ideal gas equation. Let's look at the cube vessels. Assuming all the sides are equal, and then we have A prime and A, these directions. Then when you have a single molecule of gas, the movement, the gas molecule is not stationary. When this gas moves to this direction, it collides with this wall and bounce back. Now we are going to look at the three direction of the movement of the gas molecule. The first direction is on y, x, and z axis. First and foremost, let u represent the speed of the gas molecule. N represents number of mole or number of molecules that's present in this cylinder, and T represents the time taken, and M represents the mass of the gas. From this angle now, since we are going to look at the three orientation of this movement, that is, we are going to look at it in both both y, x, and z axis. That is, the velocity of this molecule, we are going to look at it in uy, ux, and uz axis. Now, before we proceed, let's look at the movements along the x-axis first. When you take the movement of the gas molecule along the x-axis, from there we are going to resolve it on three axes. Therefore, when the gas moves from these points and hits these directions, it possesses what we call momentum. And then recall in physics, what's the definition of momentum? Momentum equal to mass times velocity. Therefore, we have mux, because we are looking at along the x-axis direction. But recall the movement of the gas is elastic collision. That when you hit the wall at this point, it will bounce back on the same direction. That is, it will rebounce back. Therefore, along A prime, we are going to have minus mu. MUF. Why is it minus? Because it returns back to these directions. Therefore, the rate of changing of momentum, that is change of momentum, equal to MUX minus MUX. Because the rate change of momentum, that is from final minus initial, this minus times minus, that is plus. At the end we have MUX plus MUX. At the end we are going to have 2MUX. That shows that along the x-axis, the changing of momentum of the gas molecule along single axis is MUX. And then when you take along the z-axis is 2MUZ. Along the y-axis is 2MUY. Therefore, since we've obtained our momentum, let's now look at the time taken for this molecule to move from one point to another. Recall that speed equal to distance over time. And let the distance is equal to L. Therefore, your U equal to L over T. But recall that the movement of the gas is in two directions, to and fro. Therefore, our L is equal to 2L. I think the distance covered from here to this one and back to the original position is 2L. Now let's make the term the subject of formula. Therefore, we have UT equal to 2L, and then T now is equal to 2L over 2L equal to over what? Over U. Now we have the time. Now from this angle now remember that here we have A prime and we have ordinary A. The rate of changing of momentum along at A is equal to 2 mux, while the rate of the change of momentum at A prime will also be what? 2 mu. Therefore, let's now look at change of momentum at A prime equal to 2 mux. We now have total change of momentum will be equal to 2 mux plus 2 mux. Therefore, at the end of the day, we have 4 mux. That's the changing of momentum in both A prime and A. Now, when you obtain this, let's now look at the Newton's second law of motion, which states that the rate of changing of momentum of a body is directly proportional to the force applied. Now, let's now look at the rate of changing of momentum of this gas molecule and the force exerted on the wall of the container. Now, let's look at this side. That is, from the second law of motion, that is force equal to delta mu over T. That is the rate of changing of momentum of the gas molecule. That's equal to F now equal to, what is the rate of changing of momentum? The changing of total momentum is 4 mux over, what's the time? Time is 2L. That's 2L over U. Now, since you are considering the gas molecule along the x-axis, the velocity will be x. At the end of the day, F now will be equal to 4 mux squared over 2L. Now, 2 goes here, 1, 2 here is 2. And then we have F now equal to 2 mux right over what? Over L. Now, this along the x-axis. Now, let's now consider this the force applied along the x-axis. Now, let's now look at the force applied along both y and z axis. Therefore, average force applied. The average force applied with F now equal to 2 mux squared over L plus 2 mu y squared over L plus 2 mu z squared over L. Therefore, we have, when you factorize this value, what's the common factor? 2m over L. That will be F equal to 2m over L into ux squared plus uy squared plus uz squared. That's what happened. Now, let's now find the average. When you resolve this, let's find the average velocity of the movement of the gas molecule in terms of n molecule. Therefore, u, which is average velocity, will be equal to, that is, u square will be equal to ux square plus uy square plus uz square all over number of molecule. That is the number of molecule of the gas that are present in the cylinder. Now, let's make where u is equal to root mean square velocity. Therefore, here you have nu square is equal to ux square plus uy square plus uz square. Now, go back to this equation now. Remove this value and put nu square in that equation. Therefore, you have F equal to 2m over L into nu square. Because if you remove this value, if you resolve it to what? Nu square, where n is the number of molecules of the gas that are present in the cylinder. Now clear the brackets, and the end of the day you have F now is equal to 2mn over L u square. Now we've obtained our force. Now let's now relate this force to the what? To the pressure exerted by the wall of the container. How are you going to do that? Recall that P is equal to force over area. That is, P is equal to force over area. But since we've obtained our force applied on the cylinder, what is area of the cylinder? Let's now resolve the area of the cylinder. Area of the cube. The area of the cube, remember that cube possesses 6 surface area. Therefore, the total area of the cube is equal to 6L square. Because L times L is one of the area, and then the cube possesses how many area? How many surface? 6 surface. That will be 6 times L square. Therefore, remove this A and substitute with this value. Then we have P now is equal to force over 6L square. Now remove this force and substitute with this value. Therefore, the pressure now will be equal to 2mnu square over L times 1 over 6L square. Because 6L square is the area. L times L, that's L cube. L times L square, that P now equal to 2mnu square over 6L cube. Was 6L cube. Now from this angle now, 2 go here 1, 2 go in 6, how many times? 3. Therefore, we have pressure now is equal to mnu square over 3L cube. Now let's now go back to the cube. What is the volume of the cube? Cube is L times L. That is L times L times L. That's L cube. Therefore, L raised to power 3 is equal to the volume of the cube. From this angle now, and the less is equal to what? Is equal to V, where V represent the volume, and then here we have P now is equal to mnu square, which is root mean square velocity, over 3V, where V is the volume of the cube. Now, this equation can now turn, take V to this side now, that will be P, or multiply through by V, that's P times V equal to m n u square times v all over v. V go with v, and then you have PV equal to, PV is equal to 1 over 3 mn u square. That's equation of the gas, where P represents the pressure, V represents the volume of the gas, M represents the mass of the gas, N represents the number of molecules, while U represents what? Root mean square velocity. Okay. Now from this angle, let's relate it to the other gas equation. Recall that PV is equal to nRT. Now remove this PV and substitute with this value. What are you going to have? And then we have nRT is equal to 1 over 3 mnv square. Now n go with n. That is RT will be equal to 1 over 3 mv square. Make me the sort of formula. That will be 3 RT is equal to mv square. Therefore, v square is equal to 3 RT over m. At the end of the day, your root mean square velocity is equal to root what? 3 RT all over m. That's equation 2. Where R is the gas constant, T is absolute temperature, M is the mass of the gas. Now, let's now go back to this equation again. Let's relate it to the density. We're going to relate it with density. How are you going to do that? Go back to this equation again. Since PV is equal to 1 over 3 mn u square, divide through by V. That is all over V over V. That is P now equal to 1 over 3 m over V n u square. Recall that density is equal to mass over what? Over volume. Therefore, remove this value here and put density there. That we have P is equal to 1 over 3 rho n u square. Now that you have 3p is equal to n u square. That is your u square is equal to 3p over density n. That's u now be equal to root 3p over what? Density n. That's 2. But let's now relate it in terms of concentration. In terms of concentration, how are you going to relate it in terms of concentration? Go back to this, the ideal gas equation again, where you have PV is equal to 1 over 3 n m u square. Now still divided by V. And then we have P V over V is equal to 1 over 3 n over V m u square. Recall that concentration is equal to mole over volume. Therefore, remove this value here and put C there. That's P now is equal to 1 over 3 C m u square. You have 3P is equal to C m u square. U square is equal to 3P over Cm. Your U now is equal to root 3P over Cm. Now, in case you are given in terms of mass and molar mass, there are some questions that involve mass and molar mass. How are you going to interpret that? Still take your ideal gas equations. That is, we have a question that involves mass and molar mass. is PV is equal to 1 over 3 nmv square. Now recall that this value n is equal to mass over molar mass, which is equal to mass prime over mm. And then from here, you can see PV is equal to 1 over 3 m prime over mm times mass times u square. They have PV is equal to 1 over 3 m square over mm times u square. That's PV times 3 times molar mass is equal to m square times u square. Therefore, your u square now is equal to root PV pressure times V times 3 times molar mass all over m